Let us look at some problems right now. So here the question is determine the sampling rate and sampling interval for x of t to cos 500 pi t and cos 1000 pi t. So this is a formula for converting whenever cos is multiplied. So this is a formula, trigonometric formula. So here a is what 500 and b is 1000. So when you solve it, a plus b will be what 1000 plus 500. So it will be cos 1500 pi t and 1000 minus 500. So it will be 500 pi t. So this is what 2 pi f1 of t and this is what 2 pi f2 of t. So when you solve it, you will get f1 as 750 and f2 as 250. The only formula that you need here is you need to know that uh, Fs, the sampling theorem is what Fs should be greater than 2Fm. Now in this 2, we have two frequencies now. So F1 and F2. So which is greater? 750 is greater. So we have to consider Fm as 750. So after consider Fm as 750, now what is the Nyquist rate? We know that at the Nyquist rate will be Fs is equal to 2Fm. So at Fs is equal to 2Fn, it should be 1000. Now they have asked us to find the sampling rate. So to find the rate, Ts is what? The formula for Ts is equal to 1 by Fs. So 1 by 1000, which we got here, will be what? 1 millisecond. So this is the sampling rate. So this was the first problem. So second one will be so here they have asked determine an Nyquist rate and Nyquist interval for the signal, this particular signal. So for I know a trigonometric formula for cos square of x. It is what 1 plus 2 cos x, right? So this is the trigonometric formula for cos square. So I'll just solve for cos square first and then I'll simplify. So phi cos 5000 pi t and this cos square 8000 pi t will be what? 1 plus cos 2 8000 pi t by 2. Okay. This 8000, this is 2 cos x, right? So it is 1 plus cos x by 2 cos x by 2, the formula. So it will be 1 plus cos 2 into 8000 pi t by 2. After solving this, I'll get this. Okay. Now I'll write this term as it is because this is a single term. But here costs are multiplied with each other. Now to solve this, we will use the formula again. That is cos 2 cos A into cos B is equal to cos A plus B plus cos A minus. So after using that formula, this is what you get. Now I can solve it for different frequencies. So 2 pi f1t will be 5000 pi t, 2 pi f2t will be 21000 pi t. So f1 will be 2500, f2 will be this one, and f3 will be this, and so on. So you got f1, f2, and f3, which is greater? So f2 is greater. So f2 is 10500, right? So whichever is greater is your fm. And now we know that fs is equal to 2fm. So I'll just multiply 2 with this and whatever value I get, that will be 1 by fs. So this is the answer for the sampling rate that they asked. Now the next question. Let the signal be sampled to be sampled be the cosine signal x of t 2 cos 2 pi in 4t. Okay. Now they have said that this is the signal to be sampled. So from the impulse we know that this is present at 4 and this is present at minus 4 with a magnitude 1. Now you can all you know the Euler's rule. What does the Euler's rule say? It says that if cos theta can be represented as e power theta plus e power minus theta by 2. So this is the Euler's rule. So uh, I'll convert cos term into the Euler's rule using this formula. So when I convert e to the e theta here theta is j theta, sorry. here theta is 2 pi into 4t. So that term here and minus this term here and so on it goes. And to find its Fourier transform, this is the formula. So x of f will be minus infinity to infinity x of t e power minus j 2 pi f t dt. Now I'll substitute for x of t. X of t was this. I'll substitute here. And after substituting, here I'll get e power j 2 pi 4t into e power minus j 2 pi f. Now if I join these two terms, it will be, if I take minus outside and j 2 pi, and the inside terms will be f minus 4 and here it will be f plus 4. So when I solve it, I'll get delta f of f minus 4 and delta f plus 4. And that is obvious because uh, the signal is present at 4 and minus 4, so it is delta of f minus 4 and f plus 4. Now it is said that it is sampled at 6 sample per second. So 6 sample per second means what? 6 hertz. Okay, so if it is 6 hertz, now we know that fm was 8 hertz. How do we know fm was 8 hertz? Because it was sampled at 4 and minus 4, so fm is basically 4. So what is Fs? Fs is 2Fm, which is 8. 2 into 4, 8. So from that we know that 2Fm is 8 hertz, and since it is sampled at 6 hertz, 6 hertz is less than 8 hertz, right? So it is undersampled. So we got to know that it is undersampled, but now we have to show it in a waveform, right? Then how do you do it? Now we knew that sample is present as minus 4 and plus 4, and the sample rate is what? 6. So we will draw first 6 here. Now we will add 6 plus 4. So 6 plus 4 is what? 10. So one wave will be with 10 and another will be at what? 6 minus 4, that is 2. This is the original one. Now around 6 I got it at 10 and 2. And the same way I'll do it at minus 6. Minus 6 minus 4 will be minus 10 and minus 6 plus 4 will be minus 2. So this is those segments. And so you can show it for 6 into 2, that is 6 at 12 also. So if 12, if you do it, 12, minus 12 plus 4 will be what? Minus 12 minus 4 will be minus 16 and minus 12 plus 4 will be minus 10 and so on. This is how you show it. So that's to revise it once again. This is the wave we have. We know that it is at plus 4 and minus 4. It is represented in this particular form, and first we need to convert it into Euler's form, because this is the formula for Fourier transform. We have to always convert it into frequency domain, right? To convert it into frequency domain, this is the formula. But since here I have it in the form, in the formula we have e to the power of something, so we need to convert it using Euler's form, and I'll get this and I'll substitute it in this formula, and after that I'll get it in the form of and delta function. And since they have said it that it is sampled at 6 sample per second, it is 6 hertz, and from the formula of Nyquist rate we know that Fs is equal to 2Fm, and so it is 8 hertz. Since 6 hertz is less than 8 hertz, it is undersampled. Undersampled means what? It is overlapping, and so the construction is not possible. So that was it. We discussed 3 problems.